This is our second part of our Solving Systems by Substitution video series that I'm making. So for part 2, again we have a system, but it's slightly different than the one we saw in part 1. Now, remember, to solve systems by substitution, our first step is to solve one of the equations for a variable, then substitute it into the second equation, solve for the variable, take that value, substitute it back into one of the original equations, and then get our second value. Yes, it is a process, so it's important to stay organized with your work. So our first step, as I just said, is to solve one of the linear equations for a variable. What that means is we can solve it for x or for y. Well, if you look at our system, if you notice, I'm going to label my equations 1 and 2. Equation number 1, it's already been solved for us for x. That makes our life a lot easier because now we don't have to do step 1. Now, if you remember back in part 1, both equations were solved for y. So again, we did not have to solve for our variable. So, since this has already been solved for x, we've already done step 1, or basically step 1 has already been done for us. Now we can move to step 2, which is basically substitute one equation into the other. Well, since equation 1 is already solved for x, that means I'm going to substitute equation 1 into equation 2. Well, how do I do that? Well, look at what equation 1 is solved for. It's solved for x. So that means I'm going to substitute this expression in for x. Well, where's x? It's right here in equation 2. So I'm basically going to take this whole expression, since we said this equals x, and substitute it in right there. So when I do that, now remember, when we substitute this whole quantity in for x, and we still have the rest of equation 2. So when I substitute this in for here, I get 2y minus 4 plus 8y equal to 16. Don't forget about the rest of equation 2. Now, as before, we solve. In this case, we're going to solve for y to figure out what y is. So I'm going to combine my like terms right here. So I get 10y minus 4 equals 16. I'm going to use my inverse operations. So I get 10y equals to 20. Again, use more inverse operations, so I get y equal to 2. Well, I now have my y value. So now I need to put y back into one of the original equations to solve for x. Again, it doesn't matter which one. Now I'm going to pick the first one because it's already been solved for x, so all I have to do is put y in, my value for y, and get a number, and it'll already be set up for me to say x equals some number. I could use equation 2, but I don't have to. I'm going to use equation 1. So here's equation 1. So I'm going to put y equal to 2 right here. Notice I use parentheses because I do have a multiplication problem here. So x equals, this is 4 minus 4, x equals 0. So according to this, my answer is 0, 2. So just like in part 1, we're going to check our answers. So we're going to use both equations to check to make sure that we do in fact get the correct solution. So for the first one, x is 0, 2 times 2 minus 4, 4 minus 4 is 0. So now we're going to check the second one. So let me write the second equation down. X is 0, y is 2. Well, 0 is 0, 8 times 2 is 16. So there we go. So this is in fact our solution to this system.